We're going to try solving a few extra braking distance practice problems. The first one here is fairly straightforward using the familiar formula D equals KB squared. As a reminder before we start, sometimes when solving these problems, you may have to do some conversions. So a gentle reminder that in order to convert from kilometers per hour into meters per second, what you need to do is take the number that you're given, multiply by 1,000 and divide by 3,600. That's because there are 1,000 meters in a kilometer and 3,600 seconds in an hour. If you were trying to convert the other way from meters per second into kilometers per hour, you would do the reverse. You would multiply by 3,600 and then divide by 1,000. In this problem, it says that the car is traveling at a speed of 53 kilometers per hour and that the car is traveling on icy pavement. Because the question says icy pavement, that tells you what the coefficient of friction or the K value should be. And in this case, it should be 0.25 seconds squared per meter. What we can solve for then is the car's braking distance. Another little reminder that you do not have to memorize the K values. So these things right here are given to you on your equation sheet, so that's not something that you need to commit to memory. So at this point, we have two of the three values that we need, and we should be good to go ahead and solve for braking distance, or D. Now, if you look closely at the values that you're given, you'll notice that the units don't match up. Your K value is provided in seconds squared per meter, and your speed value is in kilometers per hour. So this is one of those times where we're going to have to use those conversion factors that we talked about at the start of this recording in order to get our units to match up before we can proceed. So because we have kilometers per hour and we want to go to meters per second, what we're going to do is multiply by 1,000 and divide by 3,600. Now, when you do that, what you should arrive at is about 14.7 meters per second. Now, that's not your final answer. All that means is that 53 kilometers per hour is the same as 14.7 meters per second. And because our units now, meters and seconds match up, we're good to go ahead and plug this into our formula. So D equals KV squared. Our K value is 0.25 seconds squared per meter. Our speed is 14.7 meters per second, and then we need to square that. So when we do that, we should end up with 0.25, 14.7 squared is about 216.09, and so when you work that out, you should end up with a braking distance of approximately 54 meters. We're going to try a second example using the same braking distance formula, but this time we're going to try solving for a different variable, so not braking distance. If we look at the problem, it says that you notice skid marks on the road that are 12 meters long. Well, skid marks suggest that that's how long it took the car to stop once the brakes were applied. So that tells you that in this example, the braking distance was 12 meters. It also tells you that the pavement is dry, which is going to indicate that your coefficient of friction, or your K value, was 0.06 seconds squared per meter. What you're being asked to solve for this time is the car's speed. Now, this is where it gets a little bit tricky, because remember that the formula is D equals KV squared. And so if you're asked to find speed, the formula is only set up for you to find V squared. And so when we go to kind of switch this around, what you're going to end up with is V squared equals braking distance over K. Well, we're not being asked to find speed squared, you're being asked to find just speed. So you're going to have to take the square root of each side of this in order to actually find speed. And so this is the formula that you're left with. So if you want to plug in 12 meters divided by 0.06 seconds squared per meter, you're going to have to take the square root of all of that to find your speed, which in this case should work out to be about 14.1 meters per second.